All right.
What's up, Dr. Gold?
What's up, Patty, dude? How's your week
How are
doing?
you? My week's been pretty good.
Nice, dude. Yeah, same, dude. We're going into July 4th weekend, aren't we?
Yup.
Yeah. It's gonna. Are you doing anything fun for July 4th?
I'm gonna be at a summer camp.
Oh, an actual summer camp. Nice.
I'm going with some friends, so
Dope.
it's gonna be a fun time.
Dope, dude. What type of is it like something for like lacrosse or something or just a
No,
gen?
it's just like a generic summer camp.
I'm glad they're still doing summer camps, honestly. Those are like my favorite memories, dude, during the summer. I was in Boy Scouts, so I would go to summer camps like all the time and you just do a lot of funny shit. You make a lot of cool memories, you know.
Yep, I know.
Yeah, more memories than oh man, do you remember that time at Rebirth, dude, when like we had Last Circle or something, dude? Oh yo, what's up, Mango, dude? Nice. Oh, all you Team A kids, thank you for saying here. But if you already got your bond coin for Monday, so actually, yo T-Bone, you didn't get yours for Monday, so you'll get it for this session. Um, actually, I gotta call out Mango. Mango, dude, so where you been, dude? Soar's trying to 1v1 you, dude. He's he's called you out a couple times, and then you just disappear, dude. When you're supposed to go up against him. All right. Nice. Okay. Got some people in. Okay. Cool. All right. I'll ask the opening questions of. So Patty, did your math teachers give you like some summer math assignment yet?
No,
Good.
not that I've seen.
Awesome. Okay.
No.
Cool. All right. If anybody else has questions in math, now is the time. I know that we had some new kids come in this week who were like, "Oh, I need help with this." I'm like, "Yeah, dude, ask it during office hours. That's the whole point. That's why I'm here." Okay. Well, if no one has questions, so what I introduced for Team A is there's additional challenge assignments that I'm putting up, which kind of look like homework questions, but it's not really that many, dude. I think for Team A, I gave them like 8. There's like 8 like really simple questions about.
Yo, Gio, is this office house with Team B or Team or
It's for Team B. Friday, you can watch. You can watch. Like, feel free to watch. Just don't. If you get confused, it's because it's for Team B. But
see it?
yeah, all right, peace, or um, maybe I should put that on the night bot. I should say which one is Team B, which one is Team A. Um, guys, this is for Team B. Yes, I think I said it many times, but everyone still wants to claim attendance. Okay, cool, dude. All right, Senpai's like, give me coin, dude. You don't get coin for this one, dude. You got coin for Monday. Everybody can get
He
an
wants
additional
COD
coin.
points.
Yeah, I know he wants the COD points, dude. He wants dude, I saw there's a new gold character you can get, but you have to get battle pass level
Really?
100.
Yeah, the new guy.
Ah, damn, dude. Dude, fuck. Like I don't play
I
enough.
I've been off of Warzone for the past week.
Yeah, right? I think I've only played like once or twice. So,
Yeah, same here. I've been
yeah.
on Minecraft mostly.
I do see that, dude. What do you do on Minecraft? Like what's the objective?
Uh, you haven't played Minecraft before?
I've no, actually, actually that's right. I actually have never actually played Minecraft. I've seen Minecraft being played. I know you build shit, right?
Okay, yeah. So you can build a lot of stuff, yeah. People usually do that after like they defeat the bosses that are in the
Oh,
game.
there are
So that's
bosses. There's like an actual
two of
challenge.
them. Two actual ones. There's the Ender Dragon
Uh,
and the Wither.
okay.
And you have to go to a different dimension to like kill the Ender Dragon. The Wither
Uh-huh.
You have to obtain certain items to spawn him, and yeah.
Okay. I see. Okay. And then I saw there were like zombies and shit like that like pop up or something.
Like there's mobs that like spawn around your area if it's dark, like
Okay.
at night, you know.
Okay. Okay, cool. Yeah, and then I see people do speed runs. Is that a thing?
Yeah,
Where like
Dream. That's the main guy that does speed runs and stuff.
they just try to like blaze through a level real quick.
They try to they try to beat the game, which is considered it's considered beating the Ender Dragons. Yeah.
How long does that take? How many hours would that take usually?
I mean, usually people try to get diamond armor, which is like kind of hard to get in the beginning.
Uh-huh.
And they try to get diamond armor, and then they try to beat the Ender Dragon, which can take a little bit.
Okay.
But people try to speedrun and try to get it done as quickly as possible.
What's the record?
I'm not sure. It's probably under 20 minutes.
No way, dude. What? You beat an entire game in 20 minutes?
Hold on, let me
Oh
search
shit,
it
dude.
up.
That's nuts. I thought you were going to say like 2 hours or something.
Minecraft speedrun record. What is it? Wow. 9 minutes.
Ha!
30 seconds. In-game time, 9 minutes.
Oh my god, dude. Wow. So that's not including like the menus or any bullshit. Yeah.
Yeah, real time it says 11 minutes.
Wow.
That's
Okay.
crazy.
Cool. Cool. Nice. 5 says 17. Cool. All right. So what I was doing with Team A, right? I was going over. So I'm trying to get them like more or less solid on like algebra and pre-algebra. So we went over with them just what did we go over? Oh, just basic like what are variables? How do you divide variables? Like vibes. Yeah, you guys can play afterwards. And so for Team B, you guys are obviously a little bit more advanced in math and whatnot. So we're gonna get you kind of ready for like pre-calc, and like a little bit of calculus. Right. Yeah, just so so that like you see it. Like it's one of these things. Like if you've seen it before, and then you go into class and you got to go do it again, you'd be like, oh shit, yeah, I remember this stuff. Gio was talking about this like whatever time, and it won't be as like totally strange to you and whatnot. Yeah. Okay.
I get that.
He's like, I get that, dude. Yeah, it's the familiarity. All right, let's start with what we're gonna do is we're gonna do average rate of change stuff. Okay.
Average rate of change.
Average rate of change. Yeah. Okay. So you're familiar with. Oh, and can you see the? It's probably faster. Are you watching the Discord live stream, Patty?
Stream, yeah.
Perfect. Yeah, because that one's more responsive. The Twitch one's great. If all the other guys, if you guys just want to like rack up channel points, you can do that. Just leave it open or something. Okay. So let's say, for instance, we have a graph that plots the position of something. Let's say this is like position versus the time. Okay.
Yeah.
Let's say this is, and let's give it some units, like 1, 2, 3, 4, 5, 6, and let's say this is in, I don't know, like minutes or something, or let's say hours. Let's say you're going on a road trip or something, right? And you're making a graph of how many miles you've traveled in a different amount of time. So let's say this is like 50 miles, 100. You ever been on any crazy road trips, Patty?
I've driven to Colorado.
And you guys are out in
West
Philly?
Coast.
I forget. You guys are on the East Coast?
I'm in Chicago.
Oh, Chicago. That's right. Oh, yeah, dude. I love Chicago.
I've driven to the West Coast. I've driven to Colorado and Florida.
Wow, Florida? Damn.
Yeah.
That's a fucking
And
hike,
New York when I was really young.
dude. Yeah. I did I did Texas to Chicago. I had an ex-girlfriend now, but like a girlfriend at the time. She lived in San Antonio and she was going to grad school at University of Chicago. And so we drove all the way from San Antonio up to Chicago. We did it in like 2 days. It's pretty crazy.
Yeah, it's quite a while.
There's a lot of fucking nothing, dude. Like, dude, once you get like past like I forget what it is. Like once you get to Missouri or something, you're like, dude, there's nothing here.
Missouri, Kansas.
Yeah,
Yeah,
dude, I call it misery,
a
dude.
whole lot of nothing.
It's just like this place is misery. That's how I'd pronounce it.
Only thing in Illinois is Chicago, and then there's corn.
And there's corn. There's a lot of cornfields, I guess, right? Yeah.
Yep.
Okay. All right. So let's say, for instance, you're tracking your the position you have, the position you're at during at a certain amount of time. So you usually always are going to start at what we call like 0, 0, right? You've gone like 0 miles after 0 amount of time. This is usually what we call like the initial time. Let's say that you start driving kind of slow. So after 2 miles, you're going to be after 2 hours, sorry, you're going to be 50 miles into your drive. Maybe you hit like a fuck ton of traffic or something. And then let's say, after another hour, you really start like boosting, and let's say you hit like a nice free patch. You hit Missouri, and there's no traffic because there's no one that lives in Missouri, dude. Like so.
Yeah.
Except like all those, dude. I saw so many billboards for like like abortion is like hell or something. Do so many like church things. They're just like, you're going to hell, dog.
Yeah.
I'm
like all the conservative stuff, right?
Yes, all the all the stuff where I'm just like, oh, that's kind of weird. Like they're just like, God's the only person who can save me. Okay, all right, whatever.
I
okay.
believe in God, but I question some things.
Of course, yeah. I'm very open on things, honestly. If in terms of like, I'm technically raised Catholic because of my last name Rossi and whatnot, and I have 5 sisters. But church to me is like, I'm just like, whatever. There's some truth. I think we're all just pointing at the same sun, is what it is. Everyone's pointing at the same thing. We're just calling it different things.
Pointing to the same sun.
Yeah, everyone. Yeah, that's what they say. A lot of the religions are like, Islam and Judaism, all these things.
Yep.
It's all just you're all just pointing at the same shit and just calling it different things,
Yep.
But okay, so let's say after 3 hours you make it to 150, and then let's say, for instance, you decide for the next hour to be like, fuck it, I'm gonna go get some lunch at, I don't know, what's your favorite fast food restaurant, Patty?
Panda Express.
Dude, Panda, dude. Okay, nice, dude. Bomby Boy was watching, dude. He loves Panda, dude. Yeah, they used to do
orange chicken all the way.
The orange chicken is crack, dude. Do you know there's more sugar than there is protein though in the orange chicken?
Holy.
Yeah, if you look at the nutritional facts on it, dude, there are more grams of sugar than grams of protein.
Orange chicken.
Yeah, dude. It's
facts.
dude.
Let me,
It's
let
literally.
me see this, dude. You're about to ruin orange chicken.
Yeah,
for
dude.
me.
I'm sorry, dude.
Hold on.
He wants to look it up.
Wait a minute. Okay. It doesn't say sugar. Where's sugar at?
It's under carbs, probably. Let's say Panda Express.
Carbs, 19 grams. 10 grams of sugar, only 11 grams of protein.
Okay, all right. They're even. Okay, they're even. All right, but it's.
Oh my goodness.
Yeah, dude. It's basically sugar, dude. You're just eating candy. You're eating candy meat, is what I say. It's just candy meat. But that's why it tastes so good, dude.
I mean, it is what it is, right?
It is so good. I mean, yeah, at least you know what you're getting. Like, like people who trying to be like, oh, it's healthy or whatnot. Yeah.
I gotta try different kinds of chicken now.
Yeah. Their Kung Pao chicken isn't bad. Once I knew I stopped eating their Surge vibes, yeah, dude. Yeah. Nice. Yeah. All right. So yeah, let's say for an hour you chill and you eat. So your position's not going to change, right? You're going to stay at 150 between 3 hours and 4 hours. Okay. And then let's say, the orange chicken has really given you a lot of energy. So 2 hours later, you finally make it to your final destination. Which is going to be 300 miles away. Okay, cool. All right.
Yep.
So this is a graph of position versus time, okay, which tells you, and this kind of looks, this is what we would call like a function, right, because it's a line where, I can put in any time, any x, and it'll spit out like what my position is,
Yeah.
So the reason why we make graphs and stuff like this is to do different types of analysis. So one thing we could maybe ask ourselves during this whole trip is, for instance, what was my speed? Like, what was my average speed during different times, right? So the key thing here to know is that velocity is always equal to the change in position.
Oh, I've seen this on TikTok. Position over time.
Good. Yeah, change in time. Yeah. So, and this is also, so velocity is kind of like, this is like speed. Velocity is technically speed with direction is what it is, but you can also just call it speed.
Mm-hmm.
So, right. So it's equal to the change in the position over the change in time. So, and this is also kind of what you're going to see is kind of what slope is. Do you remember the equation for slope?
Slope.
Yeah, like the slope of a line.
Algebra 1 stuff, dude. I don't remember this.
Yeah, we'll go over it. We'll go over it. Don't worry. I'll show you. I'll show you why it's the slope. We'll get to that. So let's say, for instance, that they ask you a question of what was your average speed in the first, let's say, 2 hours, okay? So if we ask, for instance, what was your average speed in the first 2 hours, right? We're going to figure this out. Speed, right, is going to equal the change, right, in the position over the change in the time, okay? This we usually call delta, right? Delta just means change, is what it is. And this is just a fancy word. When we say delta position, this just means position final minus position initial. So what would it be on the bottom if it's delta time?
Delta time would be the time finish minus time initial.
Yeah, good, dude. Yeah. Time final minus time initial, right? Okay. So we said the first 2 hours. Okay. So what we're going to do is we're going to look at our graph here, right? And we're going to say, okay, where was my final position after the first 2 hours?
You were at 50 miles.
Good. Yeah, exactly, dude. Right, yeah. So see, this one's 50. So we're going to say 50 minus, and what was my initial position?
0.
0, good. And then what was my final time?
2 hours minus 0.
Yeah, good. Yeah, nice. You're getting the hang of this, yeah. Right, good. Okay, awesome. Yeah. And you can kind of see, so if we do this, right, 50 minus 0 is 50, 2 minus 0 is 2. So we get 50 divided by 2.
25.
25. And then here's a cool thing. You can get units for this, right?
Yeah, you just plug them in.
Yeah, so what were the units on the top? What were
The position was miles.
Good, miles.
So 25 miles an hour.
Yeah, good. There you go. Nice, dude. Yeah, exactly. Yeah. And this is, dude, I always hated it in school when they're like, remember the units. And I'm just like, ugh. But this is why they come in handy. It's because at the end you'd be like, okay, wait, what did I just figure out? You're like, oh, I found miles per hour. This is also how you find the slope between 2 points. So this is technically a point, right, which has an x coordinate and a y coordinate. And what were those coordinates?
It was 50 and 2.
Not quite. So the first one is always the x coordinate.
Oh wait, no, 2 and 50.
Good, 2 and 50. Good, right. And then this coordinate is gonna just be 0, 0. So
isn't that like the origin point?
Yeah, that's also called the origin. Yeah, correct. So, and what we did here, right, is we found the slope between these 2 points, because to find the slope between 2 points, it's the same equation. Slope is equal to delta y over delta x, which is just y2 minus y1 over x2 minus x1.
Oh my god,
yeah,
I remember that exact equation.
Exactly. And this is where it comes from, man, dude. It's just the change in y over the change in x, right? So y2 is like y final, y1 is like y initial, 2 comes after 1, final comes after initial. Yeah, big brain stuff, yeah.
It makes sense.
Good. All right, cool. Yeah, so that's the slope is what that is, okay? This is the average speed is what it is. So it's the average speed between 0 hours and 2 hours, okay? Now let's get it a little bit trickier.
More complicated.
Yeah. We always start simple because, simple, I want you guys to understand it, completely, and then then you start increasing the difficulty on things. So here, let me put this on the next board. Okay. We'll leave that up there. That's okay. And we'll take this out. Okay. Now let's make it a little bit trickier. Okay. Okay. Let's say I want to know what is the average speed between t equals 2 hours and t equals 4 hours. Okay? So now we're like, okay, let me find out the average speed between the second hour and the fourth hour. How do we think we figure this one out?
Okay, average speed between 2 hours. We already know is 25 miles an hour, so we can use that.
Well, okay, that's...
And
okay. That's the average speed between 0 and 2.
between 2 hours and 4 hours.
Yeah,
okay.
so now we're going between 2 hours and 4 hours.
Okay, so wait, is the third point 150 or 200?
This
It's
point is
150, right?
this one's 150, right? And this one is also going to be 150.
150.
Uh-huh.
Okay, so 150. Okay, so we're gonna do. It's gonna be like. Hold on.
So remember,
I'm
it's
trying to remember the delta stuff.
yeah, changing y.
gonna
Remember,
be-
changing y over changing x.
Okay, so it's gonna be like so y2
Yeah, what's y2?
would be y2 is 150.
Good.
They're both of the y's are.
Ah,
wait.
no. So we said
No,
t equals
150,
2 hours.
The original is 50.
Good,
So
good.
150 minus 50.
Good, very good. Okay.
And then the bottom one would be. It'd be 150 minus 150 because you're in a straight line.
It's a change in time.
Oh wait,
Change in time. Yeah.
Okay, time.
Good.
So this one is from. Okay, so we're still doing 2 to 4.
Mm-hmm.
So this is just final and initial.
Good.
4 minus 2.
Good, dude. 4 minus 2. Cool. All right. So now you get this, right? And you get, this is 100 over 2. So this is going to be 50 miles per hour.
Miles an hour.
Right? Cool. So that's the average speed between 2 seconds and 4 seconds. Okay?
Hours.
Or, sorry. Yeah, dude, if it was seconds, dude, like, you'd have, like, I don't know. You'd be like...
That's some Flash type shit.
Yeah, that's the... What's that Fast and the Furious, dude, where Dom's in the car in space? And they're just
Yeah.
like, Dom, how'd you get into space? He's like, you don't need logic when you got family.
Yeah. Makes no sense, dude. Fast and Furious is
Dude, yeah, it's always... Dude, yeah,
getting stupid now.
what does he do? He, like, deadlifts a car at one point and, like, pushes it out of the building or some shit.
I don't even know.
I stopped after, like, Fast and the Furious, like, 3, honestly. Like, I heard they're up to, like, 9 right now or something, or 10. I don't know.
What? Seriously? I haven't watched any of the new ones.
I think it's the longest running movie series, like, ever. Yeah.
Yeah, and it's getting worse and worse after.
Yeah.
I've heard.
Okay, cool. So what we did here, right, is we found the average speed between this point and this point. Okay.
Mm-hmm.
It turns out that this average speed is equal to the slope of the line that connects these 2 points. Okay.
Mm-hmm.
So that would be like this, for instance.
Yeah.
This line here has a slope of 50 miles per hour. Okay. Now, so this is the cool thing here is that Serge says they're out of ideas. I don't know, dude. I'm waiting for them to, like, I don't know, like, literally take it to, like, they have to start doing, like, time travel or some shit, like, just really, like, ratchet it, like, out of reality land.
Time travel's possible when you have family.
Okay, so the line connecting these 2 points, the slope of that would be the average speed between 2 hours and 4 hours. Now let's look, for instance, however, at the line, though, the function that goes between 2 seconds and 4 seconds. So that's the average speed. There's a thing called what we say is the instantaneous speed, okay? Which that's the speed exactly at a certain time point.
Yeah.
So we're not saying the average speed between 2 and 4 because, for instance, what's the instantaneous speed at 3.5 hours?
Instantaneous.
So how fast am I actually going at 3.5 hours in?
Well, you're not going anywhere.
Good, exactly. Yeah, nice. So your speed here, right? Your instantaneous speed is equal to 0 miles per hour, right? Because you're stopping eating candy chicken. You know, you're not going anywhere. If anything, you're probably going backwards, honestly. But
And when a line is like horizontal, right? It's always like it's like 0 because like
yes, the slope of a horizontal line is 0. That's an important thing, Patty, and we're definitely going to use that in as we get to
isn't
more.
it like because it's gonna be like whatever the y value is and then over 0. So and that's undefined, right?
Oh, okay, no. So that's different. Okay, so the reason why it's a horizontal line, okay, the reason why the slope is 0. Let's look at, for instance, the slope between these 2 points, okay? So we're going to do y2 minus y1. So what's y2 here?
Y2. Okay, y is the position.
Good.
So that's 150.
Right. And what's the initial position for 3 seconds?
150.
150. Cool. Do you see how this ends up being 0? 150 minus 150. I don't give a shit what's down here. Like anything can be down here. I don't really care because that's just going to be 0. What you're talking about, the undefined, we'll get to that.
Isn't that when it's x has a value.
Yeah, that's when it's vertical. It's a vertical slope.
Yeah.
Is what it is, right? Because let's say, for instance, you have, let's say you hit the family NOS button, and you just start like, let's say you're like right here, for instance, and you're just going straight up. Now, for instance, y2 and y1 are very different, right? But the change in x is basically 0. So this is a case where, let's say you would have like 250 minus 50, but it would be over 3 minus 3, basically. And this is dividing by 0. This is what we call like infinite velocity. Infinite, sword, dude. To infinity and beyond.
I have a question.
What's up?
2 more players for S&D. You guys time to join?
Yeah, maybe after this. Yeah, let me.
How about Gramps? Do you have it? Modern Warfare.
Does Patty have Modern Warfare?
I don't got Modern Warfare. I know it's on sale though. It's like $30 right now.
Is it? Oh shit! Maybe we should buy some copies, dude. We should probably buy some copies, Bomby Boy.
I'm down to buy it, but I'm not sure yet.
Yeah. Oh, nice. Thanks. Yeah.
They just came to act.
Yeah, we'll hit you up, dude. All right. Okay. So here's something. The concept here, Patty, that I want you to learn is that instantaneous velocity is the slope at a certain point. Okay. So let's say so you're right. This one is 0, right? Because you can see that the slope here is 0. Another thing that they'll call this is the tangent line to a point. Have you heard that word tangent line before?
Yeah.
Right. So
Algebra 1.
Yeah, right. So if I have a curve, for instance, and I'm looking at a certain point, let's say like right here, this would be like the tangent line. It's kind of like the line that just like skirts over it and whatnot, right? This right here, the line that connects 2 points, this is technically called a secant line, is what they call this.
Secant, yeah.
A secant
heard
line.
That word too.
Yeah, I know. Honestly, like, I keep fucking forgetting that one too, honestly. But so yeah, what that means. Let's see. Where's my ellipse? Where's my circle tool?
Wait, which one is the secant line again? Can you like show a different picture?
Yeah, I'm gonna show it. Okay. Let's say we have 2 points, Patty, like here, right? Okay. This line, well, if I could draw it. Okay. This is what we would call the tangent line.
Oh, I learned this in algebra this year actually too, with the circles and stuff.
Right. Yeah. So the tangent line is only ever hits the circle at one point. Oh, what's up, Bomby Boy? Hello. And then the secant line, it connects 2 points. This is what we would call a secant line.
What's it called? Like, is the line like in between the 2 points, like inside the circle, is that also called secant line, or is it?
I think they call that a chord. Technically, is what they call it.
I think it's a chord.
Yeah, I think a chord is so a line goes on forever, right? A chord is technically, I think, called like a segment, which means it has a start and a finish.
It is a segment.
Yeah. Honestly,
just like the
you never.
And the...
Yeah, like the radius and the diameter. You never really need to know this word chord. Like in all my decades of teaching, like you never need to know chord. But secant line is useful to know, and so is tangent. Okay.
Like question, like the trig functions, right? There's sine, cosine, and tangent.
Mm-hmm.
Like, does tangent like have to do anything with like this tangent line, or are those just completely different?
I think they do actually. There's a whole Let me see. There's a whole I know what you're talking about. One sec. tangent, secant, visualization. It has to do with like creating a triangle within the unit circle. Yes, it's this bitch. Here she is. One sec, where's my mouse?
Okay.
Yeah, it's something like this. Do you see how this see how the tangent line, right, is definitely tangent to the circle, and then this secant, I think it connects between the points or something. This doesn't make much sense how this is. But these are the lengths. So for instance, the tangent of an angle is equal to the length of this side of the triangle. And then the secant's equal to this. So this is how I think they're kind of related this way.
Just with just creating triangles, pretty much.
Yeah, basically. Yeah. They do some weird
And
stuff.
you can do this stuff like on a plane too, right?
Yes. Yeah. All this can be done in multiple dimensions too, 2 dimensions, 3 dimensions. But yes. So secant line this is what we call like average velocity, and then the tangent line is what we're gonna call the instantaneous. So this is tangent. This is instantaneous. It's the instantaneous slope, for instance. Okay, so looking here between 2 and 4 seconds, okay? You can see, let's say I'm trying to guess let's say I'm trying to guess the instantaneous velocity at 3 seconds. So here, let me copy this all over so we have a clearer thing. Come on. Come on, girl. Whatever. Okay. Let me get rid of this. We can leave that. Nope. Let's move that over here. This is so much easier than, dude, when I teach kids in person, dude, and I gotta keep like erasing shit and stuff, I'm just like, fuck. It takes forever. Okay. So we figured out what the average velocity was, right, between 2 seconds and 4 seconds, right, by finding the slope of this line. Let's say, for instance, I want to know my instantaneous velocity.
Between those two?
Well, let's say my instantaneous velocity at 3 seconds. So here's the key thing. Average velocity is between 2 time points, okay? Instantaneous velocity is at a single time point, okay? It's like, let's say you're running, right, and whatnot, and, you know what your average speed is running, right? But during that run, for instance, you may have sprinted during certain parts. And so in those cases, your instantaneous speed would change dependent on at what time period you were in during the run, at what exact time you were at. So let's say I wanted to try and figure out the instantaneous velocity at 3 seconds. So the first thing you could do is you could ask, okay, so wait, what type of line gives me the instantaneous velocity at a point?
What type of line?
Yeah, a tangent line or a secant line?
Tangent.
Good, tangent line, yes. So you can kind of draw this by eye, okay? Like we could look at this and be like, ooh, okay. This would probably be the instantaneous velocity, right? The slope of this line would tell me my exact speed at this point right here, or my instantaneous speed, right? Okay. So the question we can ask is like, okay, how could I get this though, right? Because how do you know to figure out the slope of a line?
Slope of the line is delta y over delta x.
Yeah, good, perfect, right. So you know you need 2 y's and you need 2 x's, right? So here, let me make a graph that looks a little easier. Okay, let's say we just have a graph that looks something like this. Okay, and I'm trying to find the tangent line at this point. Okay, I want to find the slope here. So this would be like position, right, versus time. Okay, so you know you need two y's and 2 x's, right? So
Yeah.
one thing you could do, right, is you could say, okay, I'm going to try and guess what this slope is by picking another point on the function. Another point on the graph. Oh yeah, what's up, Philip? I got hockey 7:15. Oh, can't do it on Wednesdays. Oh, we can move it around, dude. We'll move it around. It's 7:15. Wait, what? Wait, is Philip in Chicago too, dude?
Yeah.
Oh,
We live close to each other. We go to the same school.
oh, dude, dude, it's only 6:30 there, dude. What?
Yeah, it's 6:35, Philip. Come on, man.
What the fuck, dude? What? Dude, you got 45 minutes till you gotta go to hockey. I would join the call, but
He lives close to hockey too. Like,
oh, what? Oh, yo, Patty's calling you out, dog. Philip, he's calling you out, dude. He's like, what's up? I can't hear anyone. I don't know how to fix it. Input and out. Yeah, probably something on your phone. Honestly, my phone fucks up on Discord all the time. Don't worry, Philip. I'm also I record all these sessions. I put them on YouTube, so you can always rewatch them and whatnot. Because what we're gonna do after this is there will be some kind of like challenge questions based on the stuff we went over here. And you can kind of think of it as homework, I guess. It's like a light homework. And if you get those questions right, you get a ton of SCP and you get bond coins. So we're trying to give you guys more opportunities to earn points and stuff. Because I know, dude, T-Bone's up by like 5K or something, dude. Because he just keeps checking in ridiculously. Like he's very diligent with the checking in and whatnot. But we want to make it so everyone can have opportunities. So we're gonna give you guys a lot of SCP if you finish the challenge assignment for this. But it'll be over this stuff. So, anyways, okay. So let's say we're trying to figure out, Patty, the slope here, right? One thing we could do, right, is we could pick another point on our graph, right, and we could try to figure out the slope between these 2 points, right?
yeah, I see that.
Yeah, see how this would be like, for instance, this would be x2, y2, right? And then this would be x1, y1. Okay.
Yep.
So this, for instance, this would be the average speed, right, between 2 time points, right? Which it's close to probably, because the instantaneous speed probably looks something more like this, right? This blue line is probably what the instantaneous speed is, because that's the tangent to the line, right? So this is an example of showing how, like, okay, so the average speed gets close to figuring out what the instantaneous speed is, but it's not exactly it. Like in this case, it's overshooting it, right? It's because you start speeding up later, it starts thinking that, oh, your speed must have been faster than it actually is. Okay. Now let's say we bring this point even closer, okay? Let's say we bring it here. Look what happens to the secant line. Well, actually, we'll leave that one up. Let's just draw another one. Now the secant line would look something like this. Oh.
It gets closer and closer to the instantaneous.
Good. Exactly, dude. Exactly. Yeah. So as you start averaging between 2 time points that are closer and closer to each other, this is awesome. This is the whole concept we're trying to teach, and you got it right away. You get closer to what the instantaneous velocity is, or what the instantaneous slope is, which is the tangent line. It's the slope of the tangent line. Yeah. So this is a really cool concept that we're going to go over later in. We might get to it today, but what this is saying is that, okay, cool. If I start estimating the slope between 2 points, and that second point starts getting closer and closer to the first one, I'm going to get what the instantaneous slope is at that point, that first point. Does that make sense, Patty?
Yeah.
Nice. Okay, cool.
Yeah, I can see it.
You can see it, right? You can visualize it. Awesome. Okay, cool. All right. Awesome. Okay. Let's let me think what the next thing I want to do. Okay, good. Okay, so here's a good question actually. Here, let's build some practice questions around stuff. 0, 1, 2, 3, 4, 5, 6. And then could do road trips again. I'm trying to think like what's another thing that has like a rate? What sports do you play, Patty? You play sports?
Soccer.
Play soccer. Okay,
You can
cool.
do like when you kick the ball, I guess.
Oh
right?
yeah, cool. Let's do like
Way it
meters.
travels.
Yeah, the meters that. Yeah, let's do the meters that the ball travels. Yeah, let's do meters ball travels. Okay, so let's say for instance it starts at 0, and then let's have this. How high can you kick a soccer ball usually? Nice,
I
Philip.
mean, depends how you strike it, but like you can kick it pretty high.
Yeah, let's.
Like if you punt it.
Yeah, if you punt it, you're just like, yo, I'm sending this bitch to the moon.
To the moon.
To the moon. Yeah, let's say maybe you can get it like, I don't know, probably like 20, 25 meters, probably, right? Yeah.
Maybe a little higher.
Yeah.
But
Okay, let's say you kick a ball moderately, right? And
Yep.
it's gonna look something. So let's say it gets up to 30 in 2 seconds, right? Or actually, let's say it takes 3 seconds to do this. This is a physics question. We actually could solve this. Okay, and then let's say it's gonna take another. Let's say it hits like
3 seconds to fall.
Yeah, and let's say it hits some air resistance, right? So it starts falling down like slower. Let's say like a gust of wind hits or something. And then let's say once it hits the ground, it just
Bounces up again.
Oh yeah, that's cool. Yeah, let's do it. Yeah, let's have it like bounce up a bit. Let's have it just do this. Like let's have it just it's gonna light bounce, right?
Light bounce.
Light
It's
bounce.
a lot of grass.
It's a lot of grass. Okay. Here's some questions we're gonna ask. All right, we're gonna say which one is greater. Okay. We're gonna say the average speed between t equals let's say 1 second and t equals 5 seconds, or t equals 1 second and t equals 3 seconds. So which one is, if I was tracking the average speed of the ball, which one would have the higher average speed? Me looking between 1 second and 5 seconds, or between 1 second and 3 seconds?
Which one is the greater speed?
Greater average speed. Average speed.
Wouldn't it be the second one?
Good. Yes. Right. Yeah. And the reason why, you can kind of see this, right? See this? This is at 1 second, right? It's here, and then this is 3 seconds. So this would be the line in between the two, right? And the average speed would be the slope of this line, right?
Yep.
Whereas if we said between 1 second and 5 seconds, right? You see how this line, right, has a slope that's smaller?
Yeah.
Good. Okay.
Close to 0.
It's almost close to 0, right? Yeah. Because the average speed, right? Because what it is like instantaneously here, right? It's going very fast up. Then it's kind of not going anywhere, right? Slope is like 0 here, and then it's going very fast, or kind of fast down. So on average, it doesn't really have that much speed, because you're averaging big positive speed with kind of like not very much speed to like kind of negative speed, and that averages out to 0. Okay, and then let's try another one here. Same thing. Which one's greater? Let's say the instantaneous speed at 2 seconds, or instantaneous speed at 6.5. Whoa, we made it really big. There we go.
It would be the two speed.
Nice, dude. Yes, exactly, right? And the way you can look at that is, again, instantaneous speed is the tangent line. So we can look at 2 seconds,
Yeah.
right?
That one's a little bit higher
Yeah, at 6
than
point.
the other one.
Yeah, 6.5 is pretty low, right? That's right here. The tangent line here is
Mhm.
probably like that, right? So you can see how the ball's traveling a lot faster here than it is traveling here instantaneously. Yeah, good. And this is also, you could see, for instance, that the instantaneous speed at 2 seconds is greater than the average speed between 1 and 5, right? All the speed comes down to is just knowing what the slope is. This, in general, this speed thing we're doing, which is, again, comparing the y's versus the x, this is what we always call, for instance, this is rate of change, is what we say. Okay? Because what's happening is you're seeing how much the meters are changing as a function of the time. It's this could be other things, right? This could be kills in Warzone versus minutes, for instance, right? And then you could have like kills per minute, or I think the other one what they track in the game, I think is like damage per minute or something, or damage per second. Score per minute, exactly. Yeah. That would be another thing. Like this could be a graph of the score. Well, but your score never really goes down, does it?
Well, multiplayer it tracks it. That
Is this for A team? This is for B team. Someone's asking in the chat. Yeah, this is for B team. You're welcome to watch, guys. No, you guys can always watch, and you can still rack up channel points. It's just this stuff may be a little advanced, so if you're confused, don't worry about it. But please, by all means, stay, learn. At least if you see things, it starts to probably click a little bit more. Okay, nice. Okay, cool, dude. Awesome. We got through all of that chapter, dude. Yeah, this was a lot faster than Team A. Team A, dude, I'm like pulling teeth with some things.
a lot of this stuff just clicks for me.
That's good, dude. That's good. I'm glad it does. And again, like some of this stuff, right? You've seen secant, you've seen tangent. You just don't.
It's a refresh.
Very good. It's a refresh. Okay, cool. Let me see. Okay, let's look real quick at what limits are. We'll do real quick. We got 5-10 minutes here. We're gonna do a little intro into what limits are. Limits is like all of what pre-calculus and calculus is, dude. Limits.
A limit.
Yeah, limits.
No idea what that is.
Yeah. Okay. So, have you ever heard of limits, for instance?
No.
Okay. Cool.
At least not in math.
Yeah. All right. It's like push it to the limit. Okay. So limits are they sound scary, and they honestly they're taught wrong half the time. But all limits means is you're just looking at what happens to a function as you get close to a point. That's what a limit is. So let's say, for instance, we have a simple graph here. Okay. Let's say we have y is equal to x. Oh, what? I'm writing with lines. X minus 2 squared plus 2. Okay. This is a. Is this called a parabola? I think it's called a parabola. It's not a hyper.
It's parabola, but there's also another name for it.
Yeah, there's a quadratic. Quadratic is also too. It's also called a quadratic. Yeah.
It's always when it's x is squared.
Yes.
Yeah.
Yeah, quadratic is anytime you have an x squared. If we had another x in here, that would still be a quadratic, but it would not be a parabola.
Then what would that even look like then?
Okay, so for instance, let's say you had like y equals x squared plus x plus 1 or something. See how there's an extra x here and whatnot? That ends up looking something kind of like this-ish. So it kind of it'll start messing this one up is what it'll do, because this plus x will start adding values to y on the right side, and then when it's negative, it'll start subtracting values. So it ends up kind of looking something like this. But okay, so this is, for instance, this is a parabola is what it is. Okay, it's gonna look something. I can't draw totally straight today. Man. Yes. There we go. Okay, great. Okay. All right. Let's say, for instance, I wanted to know what is the value of this function as we get close to x equals 0, okay? So I know at x equals 2, right, that this function is equal to y equals 2, right? So this is what we call like 2 comma 2. Something we could ask on a function, be like, okay, well, what happens as I get closer to here? Like, what happens as I get closer to x equals 0? And a way that they write that is, let's say we call this a function f of x. Have you seen this before, f of x?
Yeah.
So all f of x means is it's basically like y equals, but this is saying I have some value f of x that depends on x. So if I put in an x, I get an f of x, which is a y. So they could say, okay, well, what is the limit as x approaches 0 of f of x? This is the same thing as saying,
Isn't it 4?
good. Yes, it is. Yes, good. This is going to equal 4. They're basically just asking, what is y when x equals 0, right? So exactly, good. So the limit,
So that's just what limits are?
yeah, well,
Just like...
this is the basics thing. We're getting to the basics.
Okay.
Yeah, the basic thing here is that, yes, is that as this x approaches 0, it's this function, f of x, the value of it is going to approach 4. That's what a limit is. A limit is basically saying, okay, what happens as I start getting close to a certain value? There's important things about limits. This is what we say. When a limit exists, and a limit exists when the x approaching a value from either direction approaches the same number. So, for instance, we came here from the right. You see this? How we came from the right and we came over to here,
Yeah.
and we got 4. If we came from the left, let's say we started here and we started coming to the left. Do you see how we would also get to 4?
Yeah.
Yeah, good. That means a limit exists. And the way they write that is this, for instance, this would be called the limit as x approaches 0 positive, which means this is from the right. This is the limit as x approaches 0 negative, which this means from the left. That's what they say. This is from the right. So this is another way to solve a limit, right, without even just doing graphically, is to literally just plug in the value. So if, for instance, we had this, right, y equals, and then let's say we put in, right, 0 for x.
Yep.
Minus 2 squared plus 2. You see how, well, actually, sorry, this should be 6. I fucked up. This should be 6. Let's put some other numbers in here. Yeah, that's what it should be. Yes, this should be 6. If I drawn my graph correctly, this would be 6. But yes, you just plug the value in, and you'll see that you get what the value is. So a lot of times when they say find the limit of blank, the first thing you should try to do is just plug that number in. So for instance, just try to plug in whatever they're asking your x to approach. So in this case, I said, okay, I'll just plug in 0. And if nothing funny happens, like if you're not dividing by 0, you're not taking square roots of negative numbers, and you get a number, you're like, cool, this is what the value of the limit is, and it exists. So here's an example where a limit does not exist, though, okay? Let's say, for instance, I have the graph y is equal to 1 divided by x, okay? Do we know what 1 divided by x looks like?
1 divided by x?
Mm-hmm.
It would be like that little line that like goes slightly up and straight in the right.
Good.
And the point that it starts would be on y1.
Okay. I think you're maybe thinking. I think you're probably thinking this one. Is that what you're thinking?
The on the y line, not the x.
Oh, okay. Good. Yes. So it's gonna look something like this. Is what it's actually gonna look like.
Oh.
Yeah, a little bit different. Yeah, you're thinking kind of close to. You're thinking a little bit of like what a square root looks like. But
yeah, that's what I was...
all good. This is what the function looks like, okay? Do you see how like this function, as we start getting closer and closer to 0, right, starts like blowing the fuck up? We can see why that is just from the math. So let's say, for instance, that your teacher asks you, okay, well, and let's say this is equal to f of x. I want to know the limit as x approaches 0 of f of x, okay? So what's the first thing that you should do to check if this to check trying to figure out this limit?
Plug in something for x.
Good, yeah. And what are we going to plug in for x?
Could it be any number?
Well, you want to plug in where you're trying to evaluate the limit at, right? You're trying to find out the limit when x goes to 0. So what you want to do is you want to plug in x equals 0 and just be like, oh, cool. Can I just get it? That's what happened here, Patty. So when we said like the limit as x approaches 0, we just plugged in 0 for x is what we did. And we just saw what we got, which was a number, which was good. Here, however, if I try to figure out, okay, plug in 0, what am I going to get?
Well, it's 1 over 0.
Good.
So
which is like
it's gonna be 1.
bad. You don't want to divide by 0.
Divide by 0.
Never want to divide by 0, dude. Dividing by 0 like breaks tons of shit, dude. That's how like the internet like breaks, you know. That and like all those Pepe memes, but yes, this is like danger is what this is, okay? Because 1 divided by 0 is technically undefined is what it is, okay?
Yeah.
So this tells us that we need to do a little bit more work in order to figure out what the limit is, okay? So what we're going to do is we're going to see what the limit is coming from the right and what the limit is coming from the left, okay? So do we remember how to write a limit coming from the right? What's the thing I put something else on here?
On the right, it's plus.
Good.
And from the left, it's minus.
Good, yes. So we're going to do the limit as x approaches 0 from the right. So that means we're here, right? And we're coming closer and closer to x equals 0, right? So you see as we get closer and closer to 0, what does my value y eventually kind of become?
What was the question?
So if I follow this function, right? And let's say I start like moving, right? X from the right. I'm going towards 0, right? Coming towards 0. What happens to my y value as I try to get closer and closer to 0?
It just goes away.
Good. It blows the fuck up.
Booms up.
Right, exactly. This is going to end up being positive infinity is what it is. Okay?
Yeah. Weren't you in our last office
Yes.
hours? You were doing something.
I was doing this,
like
yeah, and I'll show you this again. And this will make more sense to you now because it's the second time you've seen it and you've seen it in the context of limits. So now let's see if x approaches 0 from the left, right? We put a minus sign on it.
Yeah, it's going to be negative infinity.
Good. Exactly, dude. Nice. Yes. This is a classic example of where we would say the limit does not exist. This means does not exist is what they say. And the reason
DNE.
DNE is, yeah, they say DNE. Yeah, isn't like DNR like do not resuscitate or something?
Something like that.
It's something like, yeah, if you're found like unconscious on the side of the road and you have like DNR tattooed on your wrist, they're like, oh, just let him be. But
Let him be.
let him be. He's just taking a very long nap. He'll wake up eventually.
Somewhere in a very happy place.
Yeah. Well, it depends what he did.
Depends what he did.
Yeah. So right, this is gonna be does not exist. Okay. Which is because the limit approaches 2 different values from the left and from the right. And again, the way we could have kind of seen this mathematically, so 0 from the right means that x is going to be slightly greater than 0, right? Whereas x from the left means that x is going to be slightly less than 0, okay? And this is kind of what I was talking about in terms of the so let's say you're dividing by like 0.5, right? Let's say x is 0.5. This ends up equaling 2. And then let's say you have y over 0.2. This ends up equaling 5. And then 1 over, let's say 0.1. This is going to end up equaling 10. So as this x...
And as you zeros as well, it starts getting higher and higher.
Good. Yes, because as this x value that I'm dividing by, right? As that value gets smaller, right? I can put more of those into 1. And eventually I get so close to 0 that I'm so fucking tiny. Like I'm like 0.000, tons of zeros, ones, that I can put so many of those things into 1 that I'm basically at positive infinity, right? That's where this comes from. Because what you're doing is you're dividing a number by a very, very small number, which is going to get you a very, very big number. And this is a good thing to kind of know in math is like, okay, dividing by small number, getting bigger, you know.
Can I come back in a sec? I
I
gotta
work.
do something.
Yeah, go ahead. Let's see who's talking. You guys are all talking in the chat, dude. What are you guys doing? Girlfriend don't want me to play. Jack, you got a girlfriend, dude? Vibe says this seems easy so far. Good, dude. Vibes, I'm glad it seems easy. Yeah, that's the, you know, if this is easy vibes, then feel free to hop in more on the Team B lessons. Maybe, you know, which you are supposed to be on Team B lessons. Sorry, you're on Team B. I'm so dumb. Sorry. I have to remember what team all you guys are on all the time. Nice. Okay. And Philip figured out how to set the time bot. Yes. Yeah. And vibes. Yes. The secant line connects just 2 points. Yeah. Good. Nice. Okay. Good. Oh, and Ryden, you're asking, does Vibes get one for playing with you? So yes. So because Team B doesn't have as many people as Team A, I'm gonna let them play with any member of either team in order to get the bond coin credit that they get for showing up to office hours the next week. Team A, you guys have so many people on your team, you should be able to play with someone on your team. So you guys will get a bond coin if you submit something to the scoreboard that's you playing with another member on Team A. And I only Rating, you did submit something, which is good. You submitted the one with yeah, nice. Is that with Vibes actually? Who'd you play with? No. Sorry. Yeah, you submitted one, Raiden. Who is Raiden? Is your Spectre, but who's Smurf again? Sorry. That office hours. Oh, dude, glad, dude. I'm glad office hours has helped you out, dude. I'm really glad. Nice. Yeah, I gotta have you guys like write testimonials or something. Yes, or yeet, dude. You get a yeet, bro. And wait a minute, is S&D really? Is Modern Warfare on sale today, guys? I see it for $50. Where are you guys seeing it for 30? I see for Xbox One. Oh, it is $30. Oh shit. Oh, hola. Oh, okay. But this is only PC. Yeah, this is just PC Modern Warfare. No, we can't get it for console. Who else is on PC? Oh, on Game Pass. Okay. I see. Yeah, no, it's so the PC version is on sale. I see. For $30 through BattleNet, and I think maybe you can get it through Xbox Live Gold for also $30. That's a cool thing to know. Honestly, we might buy a couple copies to give out for you guys doing things this week. Let me actually, one sec. Where is my? Okay, cool. And with PS Plus too. Okay, nice. Okay. All right. Let's see, everyone. We're done with office hours for today. Thank you everyone who attended and whatnot. Team B people who showed up. You guys will get your bond coins for yeah, 30. Never thought I would see Modern Warfare and $30 in the same sentence. Yeah, that's good. It's good. So after this, we're gonna do recess. So we're gonna play some Warzone and whatnot with you guys if you want to play. Feel free to hop into the recess chat, voice channel. And we will be back on this Friday at 3 p.m. Pacific time, 5 p.m. Central, 6 p.m. Eastern. Where both teams, you guys can show up, get extra bond coins, ask some questions, and I think we're gonna be hosting another one of the trivia nights we did last week. We'll have another fun set of activities for you guys to hop in. So awesome, good seeing you guys. Let's get on and play some COD. Office hours is overrated. You're good, dude. Let's actual education. Let's do this. Let's call this recess. Warzone with us. So let's say Warzone. Close this. Right in, dude. You can come join Team B, dude. You just gotta learn some more math.
Gio.
What's up, dude?
Credit. HDR is not that bad.
Dude, the HDR is fire, dog. What are you talking about? HDR's always been fire. Here, let me throw us all in recess real quick.
I meet you there.
Okay, there we go.
What do we do?
We're gonna play some. If you guys want to play.
Yeah.
Al Prince coming in. Nice, dude. What's up, dude?
Yeet.
Yeet.
Are there any take away from any students?
No,
just
you're
got a
good.
full.
You're good. We got a full. If Patty hops on, we got a full. Yeah.
Okay.
Gio. It took me 2 days to get plat SMGs.
2 days, dude.
Heck yeah. So what are we doing? Warzone or MW?
We can do so. Oh, not everyone has MW yet, so we can do some.
Yet.
We
can-
Yet. What
Does
does that mean?
did Nico? Did you get Modern Warfare? I forget. Do you have it?
Yeah, I have it.
Okay, good. Where is I don't see you online yet. Who else is on?
Wait, can y'all hear me?
What's up?
Can y'all hear me?
Yeah, Vibes, I can hear you, dude.
Yeah.
Off-white, right? You're off-white, right?
Yeah, I had to like uninstall and reinstall Discord.
Oh, okay. All good. I got you, dude. Let me invite you in.
I need some wins, bro. I gotta carry SGU.
I gotta be the carry, dude. Do I gotta be the carry?
Yeah, you have to be the carry.
All right.
The HDR at CS too slow for me.
It's Sora and I figured out the meta today, though.
What'd you figure out?